Imagine entering the exam hall and seeing questions you can solve almost immediately, but left stranded just because you don't know the right formula behind them. In this video, I will show you the most important formulas every Jamb student preparing for Jamb physics must master. If you understand these formulas and know when to apply them, Jamb physics becomes much easier. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to consider subscribing, turn on the notification. Let's get started. I will be showing you 50 undisputed Jamb physics formula crushers from highly repeated topics. Let's begin.
Welcome to class. So the first set of formulas we will be treating is on motion. V is equals to U plus AT. Number 2, F is equals to UT plus 1 over 2AT squared. Number 3, V square is equals to U square plus 2AS. And lastly, number 4, F is equals to U plus V close bracket T divided by 2. So these are the 4 equations of motion. V is the final velocity, U is the initial velocity, A is acceleration due to gravity, and T is time. S is distance covered. Very important formulas. Take note of them. Secondly, let's talk about projectile. The first one is time to reach a maximum height is equals to U sine theta divided by G. We then have time of flight or total time of flight. It is capital T. It is 2 times the time to reach a maximum height, which is equals to 2U sine theta over G. 2 multiplied by the small t. Number 3, we have maximum height is equals to U square sine square theta all over 2G. Number 4, we have range. That's our horizontal distance is equals to U square sine 2 theta all over G. And lastly, we have our maximum range. That's when our angle is at 45. To obtain the maximum range, the projectile is set at angle of 45. So if angle is 45, 45 multiplied by 2 will give you a 90. Sine 90 is equals to 1. So that will give us a U square over G. So U is our velocity, theta is our angle, and G is our acceleration due to gravity. We will then be seeing work, energy, and power. So under work, energy, and power, now work done is force multiplied by distance, and we know that force is mg, distance can be height, so our work done also is equals to mgh. And if the work is done at an angle, so instead of just writing F distance, it will become F distance cos theta. Now, energy, we have kinetic energy is 1 over 2 mv square. Potential energy, which is the energy based on virtue of position when the body is at rest, is mgh, similar to that of work. Then we have power. We say power is the rate at which work is done. That means power is equals to work done divided by time. So what's our work done? Work done is mgh all over T. So these are the formulas, very important, crucial formulas on work, energy, and power. So now we'll be talking on machines. So under machines, we have mechanical advantage, which is equals to load divided by effort. We also have velocity ratio, which is distance moved by effort divided by distance moved by load. This is a general formula for velocity ratio, but for different kind of machines, they have their different velocity ratio. For instance, for an inclined plane, velocity ratio is equals to 1 over sine theta. For a pulley system, a block and tackle system, velocity ratio is equals to the number of pulleys. For a screw jack, velocity ratio is equals to 2 pi r all over pitch. Efficiency of a machine is mechanical advantage divided by velocity ratio multiplied by 100%, or work output all over work input multiplied by 100%. Work output is what the machine gives you. Work input is the work you put into the machine. So these are the formulas you need to master on machines. So the next one, we'll be talking on elasticity. Under this, we first of all have to introduce the law called Hooke's law, which says that the force applied on a material is directly proportional to what the extension, and if we remove the variation sign, it becomes, we add a constant. This constant K is called the force constant. So this is the formula F is equals to Ke. We have energy stored in a stretched spring is 1 over 2 Ke squared, or 1 over 2 Fe from our Hooke's law. Then we have another thing called stress. Stress is force all over area, similar to pressure. Then we have strain. Strain is extension all over original length. That's our strain. Then we have what we call the Young's modulus. Young's modulus is equals to stress divided by strain, which will give you a FL all over AE. Force multiplied by length divided by area multiplied by extension. So these are the formulas you need to master on elasticity. The next one, let's talk about temperature and thermal physics. We have our linear expansivity, which is equals to change in length. Change in length means L2 minus L1 all over initial length multiplied by change in temperature. We have our area expansivity, which is a beta, is change in area all over initial area multiplied by change in temperature. And beta is actually 2 times of alpha. Then number 3, we have our cubic expansivity or volume expansivity, which is equals to change in volume all over initial volume multiplied by change in temperature, which is times 3. Is times 3 of linear expansivity. And the last one is, if possibly the liquid is in a container that can also expand. The real expansivity of the liquid is both the expansion of the liquid alone, which is the apparent expansivity, plus the expansion, the cubic expansion of the container. So this one is for expansivity. Also, we have the heat capacity is equals to mc change in temperature, mass multiplied by specific heat capacity times change in temperature. Heat capacity is the heat required for a body to raise by 1 degree, whereas this one is for a unit mass. We also have H is equals to ml. L is our specific latent heat. Because of at latent heat, there is no change in temperature. Like for example, a solid is changing to liquid. At that point where it is melting, there is no change in temperature. So it's ml. Another one we can have is when there is a conversion from electrical energy to heat energy. So it can be IBT is equals to MC change in temperature. So these are the formulas that you should make sure you master them. So let's see formulas now on electricity. So under electricity, we have V is equals to IR, which is our Ohm's law. We also have power is equals to IV. Current is I, resistance is R, V is voltage or potential difference, P is power. We have energy is IVT or I square RT. Then we also have under electricity Q is equals to CV. Q is our charge quantity of charge, C is our capacitance, V is our voltage. Also, Q is equals to IT, as it is also in electrolysis. Then we have energy is also 1 over 2 CV square. So these are important, very important formulas you should never forget. Make sure you master these formulas for electricity. And possibly they ask you to calculate the total resistance in series, just add them, or in resistance, find the reciprocal of them, and opposite for that of capacitance. So these formulas are very important for you to crush electricity. So now let's move to another very important topic called wave. One of the most popular formula in wave is V is equals to F lambda. Now, velocity is equals to frequency multiplied by wavelength. Very important. Secondly, we have a law called Snell's law, which says the refractive index is equals to sine of the incidence divided by the sine of the refraction. Also a very important formula to take note. Number 3, the mirror formula in optics. 1 over focal length is equals to 1 over image distance plus 1 over object distance. Also, we have magnification. How big is an image compared to the object? So it's image distance all over object distance, or image height all over object height. Number 5, we have when you are being asked regarding echo. Someone speaks, it goes to strike the wall and return to the person. So in that case, velocity is not just distance over time. Because if I stand here and I speak, it goes strike the wall and come back. So the distance is times 2. So most times we use it as 2D all over time. That's the formula for echo. So another one is refractive index. For example, when you see a question like an object is placed in water and the object seems to be closer than its actual depth. So So what's the formula for that refractive index? Is real depth all over the apparent depth. The real depth is the real length or the real height of that water or of that glass block. The apparent depth is the one you presume is the depth. Refractive index also, let's say light pass from air to glass. Refractive index will be speed of light or velocity of light in the first medium, which is air, divided by speed of light in the second medium, which is what? Glass. And lastly, refractive index is equals to 1 all over critical angle, all over sine of critical angle. So refractive index is equals to the inverse of the critical angle. The angle that if the incident ray exceeds, it is totally internally reflected. It undergoes total internal reflection if the incident ray exceeds this angle. So these are the formulas you need for wave. And lastly, let's talk about modern physics and radioactivity. So under radioactivity and modern physics, the number of material remaining all over the initial is equals to half the time taking divided by the half-life. Also, the decay constant is equals to 0.693 all over half-life. You know, we say half-life is actually the time taken for a material to decay or to decompose to half of its original size or mass. Then we have uncertainty principle, Albert Einstein, who said E is equals to mc squared. Energy is equals to mass times velocity squared. Also, we have our Planck own that says E is equals to hf. Planck constant frequency energy is also equals to hc over lambda, because our c is equals to f lambda. That velocity is equals to f lambda. So they just collected, they just solved it and it became hc over lambda. So these are very important formulas you need to master on radioactivity or on modern physics.
Welcome back, and hope you enjoyed that class. In this video, we shared approximately 50 formulas from highly repeated and predictable Jamb physics topics, ranging from motions, projectile, work energy and power, elasticity, machines, electricity, temperature and thermal physics, wave, and lastly, radioactivity and modern physics. If you master these 50 formulas and understand when to use them, I bet you are prepared for Jamb physics. Please, if you find it difficult or you imagine how will this be possible to master these 50 formulas, I made a simple video on how you can be able to master any physics formula with ease. Please check. Or your challenge is how to know when to use a particular formula. How can I be able to always solve my physics problem and get or reach to the right answers? I also made a video where I shared 7 steps, 7 blueprints to solve any physics problem. You see, Josh White Academy has you covered. So please do well to hit the subscribe button, turn on the notification, like, share, and comment. I am your host, Josh White, leaving to catch you another day. Shalom.